Hello, hello, my friend, and good afternoon to all of you. And today, uh, we want to present about our group project SSK 3207 and topic parallel processing and multi-core computers. And our task is about topic multiple instructions, single data stream, MISD, processor organization with shared memory, and multiple instruction, multiple data stream, MIMD, processor organization with shared memory. Uh, my name is Muhammad Faris Ikhwan bin Badarullah, 200-538, and next.
My my name is Liang. My metric number is 208863. Next.
Okay, my name is Junhao and my magic number is 204830.
Okay, let's we start our presentation. Yes, please.
Today,
You want Liang, yeah?
yeah, today I wanted to introduce to you is a multiple instruction stream, single data stream, and multiple instruction stream or multiple data stream. First of all, let's understand what is a multiple instruction stream, single data stream. It is a structure of a parallel computer. It can be called MISD. MISD has a processing units and performers different processing on the same data stream and its intermediate result according to the requirements of output of one processing unit is used as the input of another processing unit. On the other hand, multiple instruction stream and multi-data stream, it can be called MIMD. It is a technology used to achieve parallelism. The MIMD computers have multiple synchronous and independent working processors. In any clock cycle, different processors can execute different instructions on different data segments. That is, execute multiple instruction streams at the same time, and these instruction streams operate on different data streams respectively. The MIMD achieve architect multiple application fields such as computer added simulation, modeling, and communication switches. MIMD matchings can be of the shared memory or distribute memory category. Shared memory matchings include UMA, NUMA, CUMA. Distributed memory matchings include NORAM, and so on. Then I want to explain organization diagrams with um, MISD and MIMD. In MISD, there are n processor units, each receiving distinct instruction operating over the same data derivatives. This means one processor. On the other hand, in MIMD, there is more than one processor unit having the ability to execute several programs simultaneously. This category involves most of the multiprocessors system and multiple computer systems. That's all. Next.
Okay, and this is my turn, and want to explain about MISD architecture. More of an intellectual exercise than a practical configuration. As about MISD architecture is fieldwork and but commercially available. And this is the diagram for MISD architecture. You can look this. And next is MIMD architecture is not unlike SISD, MISD, and MIMD. Computer works asynchronously. It means SSD, MISD, MIMD cannot synchronize the computer like MIMD because two of these MIMD can share memory and distributed memory. That means tightly coupled and loosely coupled. And this is how MIMD architecture works. And now is distributed memory MIMD and communication IPC on high-speed network. Network can be configured to anything 3 mesh cube, example like that. And unlike share MIMD, because easily or readily expandable and highly reliable, it means any CPU fail does not affect the whole system. There's diagram for distributed memory MIMD. And next is share memory MIMD machine. Communication source PE is processing element, write data to global memory and destination retrieve it. Easy to build. Conventional access of SISD can be easily be ported. Limitation of MIMD machine is reliability and expandability. A memory component or any processor failure affect the whole system. It is also increase of processor leads to memory contention. And the example of MIMD machine is silicon graphic supercomputer. That is how it works. Okay, next is about MISD, multiple instructions, single data. A single data stream is fed into multiple processing units. Second is each processing unit operates on the data independently via independent instruction stream. Few actual examples of this class of parallel computer have ever existed. One is the experimental by Carnegie Mellon C. MMP computer in the year 1971. And also some conceivable use might be multiple frequency filters operating on a single signal stream, multiple cryptography algorithm attempting to crack a single code message. Here's a picture of MISD instruction. Okay. And next is MIMD, multiple instruction, multiple data. Currently, the most common type of parallel computer. MIMD also most modern computers fall into this category, and MIMD have multiple instruction because every processor may be executing a different instruction stream, and it also can have multiple data. It means every processor may be working with a different data stream, and execution can be synchronous or asynchronous, deterministic or non-deterministic. Examples: most current supercomputers, network parallel computer, grids, and multiprocessor SMP computers, including some type of PCs. As MIMD is better than MISD for user in computer. And there is advantage and disadvantage of MISD. MISD good in excellence for situation where fault tolerance is critical. But MISD have a disadvantage, like machine built using MISD model are not useful in most applications because they are unavailable to commercial. And lastly, for me, MIMD. MIMD have a lot of advantages, such as great for situation where you need to perform a variety of processor and data intensive tasks. Example, when you use many application on your computer laptop, you want to doing video editing or game or playing game, it's very useful for computer to to easy the line. Okay. A second is reliable, scalable, and efficient. Yes. But it is have disadvantage, but it is just costly and sometimes complex to implement. That's all from me. Thank you, and I will pass to Junhao.
Okay. And I will tell the real implementations for the MISD and the MIMD. Okay. First, we talk about the MISD. MISD use the so, but to compete for the MIMD has more effective to do their things. So MISD is only a theoretical model. It not use the applications in our daily life, or it only used for the research project. Next. So I will tell you a single example of that. It is used for the spaceship controlled computing. But this system is built in the 1984. So we do not know how exactly it cost. And we do not know it is still useful nowadays or it's just useful that years. And I will tell you the other example. Okay, next. The other example is the arrays called the systolic arrays. Actually, it is not a pro MISD systems, but nowadays we also referred it into the MISD. For the systolic areas, I think it is cost so many monies to build it, but actually it faced for the AI and image processions, computer visions, and other tasks which animals' brains do so particularly well. But due to the highly special states, it needs so many customer hardware. That's why it is cost so many money, because in the research project we need to build the huge systems. So its application is especially for the research, not so many widely for our daily life. Next. But to the MIMD, it is so different because any processes with the multiple cross or more precisely multiple instruction issues units that can float in department programs paths is the MIMD processors. Next. So almost any modern desktop or laptop processors, the GPU, CPU, and our mobile processors for the phones and the table list have the MIMD systems. It seems that have not poor MIMD computers for the market, but we also build a huge poor MIMD system for the research project. Next. So therefore, we range the component use the MIMD system. And we can also have so many pressures of it. First of all, the specifications for the MIMD system, from the small self-built systems to our use the mobile phones and the personal computers, laptops, massive computing survivors, and our research project machines in the lab. That means its price have the range from around, I think, 115 ringgit to maybe 15,000 ringgit or more higher. And it is used for so many applications areas, such as the computer additions, designs, and simulations, modeling, and as the communication switches. So it has the huge reach for the applications such as the people daily lives, the medical, and the AI, and the visions intelligence systems. Next. And communication. The conclusions of this MIMD and the MISD.
We have 1 minute.
Okay. For the truth, the MISD, it works using the multiple instruction streams to process a single data stream. Next. Have a rail called the synchronic rail for the AI, and it is only used for the research project because the MIMD is more effective to use in the daily life. So it particularly score is very narrow. Next. But for the MIMD, it is different. MIMD machines can simulation delete and extensions the multiple instruction streams that operate on the different data streams. Actually, the latest, the multiple code computation systems of that code can use the MIMD system, such as the Intel or AMD CPUs. In fact, not only the CPU, but also the modern desktop GPUs or mobile phones have the MIMD system. So it can use for the high-end research, multi-material, and so many other fields. Next. In summary, MIMD is more widely available and less expensive than MISD, and it is more effective than the MISD based on the actual premise of how their system works. So thank you for watching our presentations for the MIMD and the MISD. Thank you.
Thank you all. That's
Thank
all.
you all.